Okay, another algebra quickie here involving fractions. I've got x over 4 equals 2 over 3 plus x over 6. So I'd quite like to get these fractions to disappear. So I'm going to try and get the over 4 to disappear, and I'm going to get rid of the x over 4 by multiplying it by 4, and then I'll just have x. But I need to multiply everything else by 4 as well to maintain the balance. So 2 over 3, and I'm going to multiply it by 4, so I'm going to have 8 over 3, and then x over 6, I'm going to multiply it by 4, and I'm going to have 4x over 6. So I've got rid of one of the fractions. Let's get rid of the dividing by 3 bit in 8 over 3. So let's multiply everything by 3, and then I'll just have 8 there instead of 8 over 3. The line in a fraction just means divide. But of course I've got to multiply everything else by 3 to maintain the balance. So instead of x, I'm going to have 3x. And instead of 4x over 6, I'm going to have 12x over 6 because I've multiplied everything by 3. Finally, let's get rid of the last fraction by multiplying it by 6. There is another way you could do that, spotting that 12 divided by 6 is 2 anyway, but we'll do it the long way. So multiplying by 6, the 12x over 6 just becomes 12x, but to keep the whole thing balanced, I need to multiply everything else by 6 as well. So the 8 becomes a 48 when I've multiplied it by 6, and the 3x becomes an 18x multiplying that by 6. So I've got 18x equals 48 plus 12x. I've got x's on both sides, so I'd quite like there only to be x's on one side, so I'm going to take as much x as I can away so that it disappears from one of the sides. So if I take away 12x from both sides, that leaves me with just the 48 on its own on the right, but I've got to take away 12x from the other side as well, so I'll just have 6x left. 6x equals 48, and divide everything by 6 gives me x equal to 8.